Hi, I'm Alex. So I'm gonna work on my assignment 2. So first of all, we're gonna uh, find a path. This is gonna be the path of my CSV file iris, and then we're gonna save it as a variable, as a file name, and then we're gonna import the pandas at PD, and then we're gonna read the CSV file, and then gonna print it out. And then we're gonna print the first 5 rows, which is we're using the hat method. And next question, we're gonna replace the species column value with its corresponding integer, which is 0, 1, 2. And so in this step, the target variable originally has 3 classes, a cetosa, a versicolor, and a virginica. We replace the cetosa with 0, versicolor with 1, and virginica with 2. So we're using the replace with the species with the 3 classes. So we're gonna print it out with the first 5 rows again, make sure it's correct. And then we're gonna select the first 4 column. So we're using the iLocation method, and then we're gonna print the first 4. So this is gonna be the 4, and then we print it out. So the species disappear. So and then now we're gonna do the last column. We use a -1. It means the last. So we only printed the species column. And then for the 4, and then so we're gonna check the first 5 rows of the xtrain, xtask, xtask, and the ytrain, ytask with the hat. So we're gonna print the first 5. So now, we can use we're gonna print the length of the xtrain and xtask. So this is gonna print the length. So the number is 120 and 30. So we use the length method and then passing the xtrain and xtask parameter in it. So we're gonna use convert the ytrain and ytask into the categorical. So we're using the numpy. So because we don't use characters, so this will create the 2 numpy arrays, 1 hot train labels and 1 hot task labels, each with 3 columns, 1 for each class, and as many rows as there are example in the corresponding sets. The ith rows of each array will contain 1 in the column corresponding to the class of ith, the example, and then 0 second everywhere else. So this is basically equivalent to using the caret 2 categorical function. So for the 6, so in the first layer we specified 100 hidden units and a value activation function, and we input shape to 4 comma space, which means that the input data has 4 features. Second layer specified 100 hidden layers and a value activation function. Last layers we set the number of output unit to 3, which is the number of class we have. And we also have an activation function to softmax, which is to appropriate activation function for multi-class classification problem. So we compile it. So we use compile methods. So we set the optimizer to RMS prop. It's a popular optimization algorithm for the neural network, and we specify the loss function, and we use a categorical constant trophy as the loss function, and then we set the metric to accuracy to evaluate the performance of the model during the training and testing. And in the 7a, we fit. So here's a model. Here's a model is the equation model we defined earlier. Xtrain is the input train data, and one hot train label. The one hot encoded training labels equals 20. Specify the number of times to iterate. And then the batch size equal 10. Specify the number of samples to use in each iteration. So for 8a, so the evaluate method return two value, which is the loss value and the accuracy value. So we only need the accuracy value, so we printed the console. This is the accuracy. So 9a, so it's gonna and we have set the input shape parameter of the first layer to 4, and mean is expect the input data with 4 feature. The softmax activation function is used to in the last layer we have multiple classes, and then compile the model using the RMS prop optimizer appropriate loss function and the accuracy. So, and then we're gonna fit the data. Yes. And then I'm gonna evaluate the model on the test data. It's gonna be the accuracy. So for 9b, there we go. So we compile it. So we compile it with the optimizer this, loss function this, matrix this. So we're gonna fit the data into the in the history value. So this is for the fitting model. So because and then the 9c. So here's we create a sequential model and add the 3 layers to it, 2 dense layers with 10 hidden units each, and ReLU activation function, and 1 dense layer with 3 output unit, and the softmax activation function. So we then compile the model using RMS prop as the optimizer, and then the loss function as well, and accuracy as well. Finally, we fit the model to the training data. Xtrain, 1 hot train labels equal 4, batch size equal 10. There we go. And then 9d. So we first use the predict method. to get a predicted probability for each class for the test data. Then it converts these probability in integer class label by selecting the class with the highest probability using the argmax. And then using the argmax and the function and similarity, it converts the true labels to integer class label. And then at the end, it compares the predicted and the true label to calculate the accuracy. The result is going to be in percentage format, 80%. So what we learned. So what I learned from this assignment, so basically I learned the number of layers and the hidden units in a neural network can impact its ability to learn from the data and generalizer to new data, increasing the number of layers and or hidden unit can increase the capability for a model to learn complex pattern in data. And also overfitting occurs when models learn to perform well on training data but does not generalize well to new data. It's not always present, but it's something that should be monitored during the training. And 10. So, so we also so in 10 we also use a sequential neural network model with 3 layers as well, with 4 layers as well. Yes, and the input shape is 4, and then we have a ReLU activation, and then the softmax, and then we have 32 neurons with a ReLU, and then the softmax as well we use for the multi-class classification. And then next time we use a mass optimizer as well, and then same loss, same matrix, and then we're gonna fit the data as well, and then we're gonna store in the history variable. Compile it. Yeah, pretty much that's it. Thank you.